All right, section 4.5, graphing linear equations in standard form. So a few sections ago, which was like 2 weeks ago, we learned a fancy way of writing equations, which was ax plus by equals c. Question mark not included. That's standard form. Not to be confused with slope-intercept form, which is y equals mx plus b. Slope-intercept form is great to graph using the y-intercept and then using a slope. The slope then is your directions to a second point. Because how many points do you need to graph a line? At least 2, right? Hopefully, if you got more and they line up, that's just confirms that your answer is correct. But you need at least 2 to graph a line. Well, today, instead of using slope-intercept form, we're going to use standard form, and we're going to graph using the x and y intercepts. I showed you an example of this in your previous notes, but it has been a while. So we're going to have our own notes to go over that again. Before we do that, just to get used to using standard form is often what we use when we're looking at story problems. So this problem says, work with a partner. We're not going to do that. Work with me, even better. You sold a total of $16 worth of tickets to a school concert. You lost track of how many of each type of ticket you sold, though. It looks like, according to the tickets, that each of the adult tickets cost $4 and student tickets cost $2. So what you would do is, since we don't know the number of adult tickets, we'd have to use a variable for that. Let's just call that x. X represents the adult tickets. How much was each adult ticket? 4. So once I figure out how many there were, I would times it by 4, call it 4x, $4 per ticket. Plus, I'd have to add that with however many student tickets I sold. Let's call the number of student tickets y. How much was each student ticket? $2. So let's call it 2y. So we have 4x plus 2y equals, and then did they tell us what the total was? How many dollars worth of tickets did we sell, Lizzie? 16, right there in the problem, $16. That is an equation in standard form. 4x, I'll write it better for you. 4x plus 2y equals 16. So standard form is often what we use with story problems. It's also pretty easy to graph, but I'm not going to graph it using slope-intercept form. I'm going to graph it using a different technique. So it says, write and complete the table. Copy and complete the table. I'm not sure why it says copy. Probably because it wanted to do it on your own paper. We're not going to do that. Complete the table showing the different combinations of tickets that you might have been able to sell. So what's the lowest number of adult tickets we could have sold? How many? 0. If we would have sold 0 adult tickets, all $16 would have come from student tickets. And since each student ticket is $2, how many student tickets would that have been, Carter? 8. Nice job. I could also have sold 1 student ticket, or sorry, 1 adult ticket. Now that's $4 if I sell 1. So now we're at 16 minus 4, which is 12. If the rest of them were student tickets, what's 12 divided by 2? 6. I could have sold 2 adult tickets. 4 times 2 is 8. So 16 minus 8 is also 8. What's 8 divided by 2 for each student? And so you can finish this pattern, can't you? 0, 8, 1, 6, 2, 4, 3, 2. And if I sold 4 adult tickets, that would be all $16. I wouldn't have sold any. So if I forgot how many tickets I sold, these are the only 5 combinations that work because you can't sell half tickets. All right. It says plot the points from the table. Describe the pattern formed by the point. So we're going to plot 0, 8. Remember, 8 is the student tickets axis, and X is the adults ticket axis. So 8 student tickets means I didn't sell any adult tickets. 1, 6 means I sold 1 adult ticket and 6 student tickets. 2, 4, 2 adults, 4 students. 3, 2, 3 adult, 2 student tickets. 4, 0, 4 adult tickets, didn't sell a single student ticket. Now, normally, I would connect these dots and make a line. I'm not going to do that for this example. If you were listening, I told you why. Why wouldn't I be connecting these? Julia?
You can't have.
Correct. I can't have any in-between values, half, third, fourth, can't have any in-betweens. I can't sell 4.2 student tickets, right? So this would be what we call a discrete function, where I can't connect the dots. Whereas if I were able to connect them, that'd be what we call a continuous function. You'll talk about those next year, discrete and continuous functions. If I'm pumping gas at the gas station, can I pump 14.8 gallons? I can't. So that's a continuous function, but I can't sell 14.8 tickets. Questions on that? Okay. Let's do the next one. Cheese for sale. Interesting. It says you sold a total of $16 worth of cheese. You forgot how many pounds of each type of cheese you sold. Sounds like we have Swiss and cheddar. So Swiss is $4 per pound. So if X is the Swiss variable, I would say 4X. Plus I need another variable to represent the pounds of cheddar that I sold. Each pound of cheddar is 2, so 2Y equals 16. This is the same equation as before, isn't it? Okay. Now, what's different about this is, can I sell half a pound of cheese? I could. If I have a scale, I can sell any of these in between values. So this would be a continuous function. So when I plot these points, and if you want, you could just copy and paste. It's not cheating, you're just copying yourself. You could copy and paste those points, but this time we're going to connect them with a line because we can have those in between values. What I'm not going to do though is put arrows on my line, which is something I hate not doing, right? But I can't go in both directions. I can't sell negative Swiss cheese and I can't sell negative cheddar cheese. So I really only have those values. Nothing in quadrants 2, 3, or 4 is going to work because I can't have negative pounds of cheese. Now, this one does ask us to do a little bit more. It asks us to take this equation, 4x plus 2y equals 16, and it does say to write it in slope-intercept form and then graph. We've already graphed it, but let's go ahead and write it in slope-intercept form. We've done this before. Move the x variable over to the other side. 2y equals negative 4x plus 16. Remember when we write it, we squeeze it in front of that constant value. Divide everything by 2. Y equals negative 2x plus 8. This equation is the same equation that we did in the last problem with the tickets. And if I were to graph that equation, this equation tells me that I have a y-intercept of 8. Check. I have that point here. And my slope is -2 or -2/1. So down 2/1 and check. That is my slope. They're just two different ways of writing the same equation. Two different ways. So this is called slope-intercept form. This one right here, we're used to this. This is called standard form. And the difference is that standard form is not solved for y. It's got x, it's got y. It's actually solved for the constant 16. Yes?
So when I have to do my homework,
Yeah. I hate to do that, but what I'm looking for on your homework tonight is to see what the x and y intercepts are. Now, you should be able to tell what your y-intercept is each time, but you would at least have to show me the work to find your x-intercept. So I'll show you what that work's going to look like. You may not have to do a whole lot, or you might just decide to scrap it. I don't know what you want to do, but depends on what you've already done. Does the value x equals 2.5 make sense in the context of this problem? Yes, you can sell 2.5 pounds of Swiss cheese. Hey. Oh, yes. Can I head down? Can I head down after school or are you? Okay, when do I need to get, can I come down between passing periods? Okay, I'll do that. Bye. Okay, yeah, this is not a discrete function. This is continuous. I can sell a ½ pound of cheese or 2.5 pounds. Okay, we're gonna skip that, all that. We're gonna move down to our actual notes then. Really? No sarcasm intended at all.
He said both. He said yay. I didn't say no. You said no.
All right. The standard form of a linear equation is ax plus by equals c, where a and b cannot both be 0. Because if a and b are both 0, you don't have an equation anymore, and we don't have a line. One of them could though. Like if I plugged in 0 for a, that would cancel out my x variable, and I'd end up with something like 2y equals 8. And 2y equals 8 would just be y equals 4. Can you graph y equals 4? What would y equals 4 look like? No, you're all wrong. You're right. I know you're just raising your hand. I'm joking. Yeah, it'd be a horizontal line, right? Or if I plugged in 0 for y, I get something x equals something, and I would get a vertical line, right? That's an undefined slope, but it's vertical. They just can't both be 0. It says, can every linear equation be written in slope-intercept form? The answer is no. Vertical lines cannot be written in slope-intercept form. Because vertical lines have what kind of slope? Yeah, so no lines with undefined slope. Those lines exist. Heck, they even have equations, but we have to start them with x. Well, standard form doesn't worry about that. Standard form is useful for finding intercepts. So you're familiar with the Y-intercept. Now we're going to be finding the Y and the X-intercept. Remember, we did this in a section not too long ago. We said that anywhere on the x-axis, all the y values are what? Anywhere on the x-axis, all the y values are 0. So -6, 0, -5, 0, -4, 0, 2, 0, 3, 0, 4, 0, 5, 0. The y values are always 0. Anywhere on the y-axis, the x values are always 0. So with that given information, we're going to plug in 0 for y to find the x-intercept, and we're going to plug in 0 for x to find the y-intercept. Remember, we only need 2 points to graph a line. Today, instead of finding the y-intercept and then using the slope to find another point, we're going to use the y-intercept and the x-intercept to graph our line, because those are 2 points that we'll just connect them to make a line. So to find, I feel like it's a bit redundant. It's probably because I have to repeat myself so many times because people mess this up. To find the x-intercept, plug in 0 for y. To find the y-intercept, plug in 0 for x. With these 2 points, you can graph the line of the equation. So we're going to find out what x is, we're going to find out what y is, and we're going to graph those 2 points. Okay, so this is what your homework should look like. They're going to give you an equation. You're going to plug in 0 for y. If you do that, that goes away. And you're left with -2x equals 12. If -2x equals 12, what's x equal to? Xander?
-6.
-6. So I know that when y is 0, x is -6. So I'm going to graph the point -6, 0. And -6, 0 is right here on the x-axis because it's the x-intercept. To find the y-intercept, we're going to plug in y, or x for y. So we're going to cancel this out. Sorry, I said that wrong. We're going to plug in 0 for x. We're going to cancel the -2x out because plugging in 0 just gets rid of that. And we're going to be left with this equation, 3y equals 12. Carson, if 3y equals 12, what is y equal to? 4. So when x is 0, y is 4. And I'm going to plot that point. and then I connect them and I make a line. So for those of you that already started, your slope-intercept equation is going to have the y-intercept as part of the equation. I would at least need you to do this to find out what your x-intercept is. So go ahead and show that work by plugging in 0 to define the y. For those of you that haven't started it, you would plug in 0 for x to find your y-intercept, plug in 0 for y to find your x-intercept, and then you would just do that work on your paper. The graphing does not have to be shown on your paper. It never does, right? Just leave it. Just graph it on the iPad and be done. Okay, next one. To find the x-intercept, plug in 0 for which variable? Owen? The y. Yeah, it's opposite. So Owen, if you plug in 0 for y, what's this equation now say? That's right. Jimmy, what's the opposite of multiplying by negative a half? Not dividing by 2. You've already flipped it, but you forgot you changed it. So dividing by negative 1/2 is the opposite of, timesing by negative 1/2 and dividing by negative 1/2 are opposites. But dividing by negative 1/2 is the same as timesing by negative 2. I think that's what you meant to say, and it just wasn't coming out right. So we're going to times both sides by negative 2. What he's doing is he's multiplying by the reciprocal. Okay, not the negative reciprocal. This isn't perpendicular lines. I'm solving an equation, still have to get rid of the negative. Jimmy, what is 3 times negative 2? Perfect. So x equals negative 6. What does the y equal? What's the y value at that point? 0. Yeah. Remember we plugged in 0 for y. That's why this whole thing worked out for us. So I want you to plot negative 6, 0. It should be the same as it was last time on the x-axis right there. Then we're going to plug in 0 for the x to find the y-intercept. So this now goes away, and you get negative y equals 3. Garrett, if negative y equals 3, what's y equal to? That's right. So we're going to go over to the point 0, negative 3 is on our line, and we'll go over to the y-axis and plot negative 3. And then we can graph the line that goes to those points. Just another way of graphing. Convenient if you are good at doing mental math in your head. Right, if you can plug in 0, and I mean, obviously I'm going to make you write this down because I got to see what's going on, but it would be quick and speedy if you didn't have to write it down and it was easy. Now, if I give you a bunch of fractions, that may not be as easy, but like this problem here, it's easy to see that it's 6 times negative 2 that gets you 12. And it's 4 times y that gets you 12. And so that would be your x and your y-intercepts. Of course, you can still graph an equation using slope-intercept form, which is y equals mx plus b. So what they're going to do is they're going to, on a few problems tonight, they're going to give you an equation that's in standard form, and they're going to ask you to convert it anyways, but without graphing, just convert it to slope-intercept form. So in order to do that, you would then just solve it for y, which is what we did in that Swiss cheese and cheddar cheese problem we did to start off these notes. So these were the 2 standard form equations. What we're going to do now is write them in slope-intercept form. Connor, tell me the first thing you would do to write that in slope-intercept form. Good. It's going to give us 3y equals x, 2x plus 12. And now what, Connor? Okay. So what do you get when you divide 2x by 3? Good. Just 2/3 x. Don't make it harder than it is. And 12 divided by 3. Now, if I go up 2 examples, I should be able to see y equals 2/3 x plus 4. There's my plus 4. Here's my rise 2, run 3. There's my 2/3. Makes sense. That works. That's the right line. On this one, to solve for y, what's the first thing you would do, Emerson? Okay. That would give you negative y equals 1/2 x plus 3. Now what would you do? It's a good way of saying it, right? Make everything not negative. So take the opposite of everything. So negative y becomes y. What's the 1/2 x become? And the 3? Don't put plus minus 3, just minus 3 will work. I see people do that a lot. And I'm like, it's just confusing you. And so if I go up to that last example we did, I should see a y-intercept of -3, and I should see a slope of -1/2. Here's my y-intercept of -3 and my slope of down 1/2. Well, my line's not super good, but if you follow it enough, you get to the point that I graphed. Down 1/2. They're the same equation, just two different ways of writing it. Oh, okay. I guess that goes there. Probably should have not spaced that out as much. That confused me. I was like, was that part of the directions? But no, it's not part of the directions. I'll just do that. And I'll move back up here. That was a complete waste of time. There we go. All right. Write each equation in slope-intercept form, then graph the equation. Okay, so this time we will graph in slope-intercept form. The reason I'm having you do this here is because I believe there are 2 or 3 questions on tonight's homework. You have to check the note that I posted. So there are 2 or 3 questions where you are, maybe it's just 1, but you are using slope-intercept form because the intercepts don't work on that one. I think there's one where you get like an x-intercept of like 7/16. It's not very easy to graph, so we're just going to use slope-intercept form on that one. But this one's pretty simple to use the intercepts or use slope-intercept form. If I'm using slope-intercept form here, I just subtract the x over and get y equals -x minus 2. Martin, what is my y-intercept in that equation? Good. And if I said that my slope is negative, well, what is my slope? -1. Does that mean go up 1, right 1? Or does it mean go down 1, left 1? So it doesn't mean either of those. Good. I was trying to confuse you because that's what my Math 7 students are doing right now. When they see negative slopes, that mean to them that means go down and left. But if you do that, what kind of slope do you end up with? A positive slope. Yeah. So only one. So Martin's right. Go down 1, but then still go right 1. And then that puts a point right there. And really, as many points as we want to put, we can make a line that goes through all the way through our graph like this on that side, and on the other side should look like, oh, that wasn't really good. Should look like this. Example B. Christian, help me turn this into slope-intercept form. Okay, what's that going to give you? That's it? Oh, so what's the y-intercept? So what's another word we have for these types of equations? Oh, come on, it was just last week. Lizzie? They are proportional. They are direct variations or proportional relationships, either one of those. Yeah, so if it goes through the origin, that's actually what my Math 7 students are learning today. They're learning direct variations. And so all these lines are going through the origin. Instead of being y equals mx, they learn it as y equals kx because k is the constant rate that it keeps going up by. I wish they just called it m, but the book calls it k, so they have to learn m next year.
Silly.
So rise, I know, it's just a waste of time. Rise 2, run 3, and we're going to go all the way through that point. Go down 2 and left 3 and all the way through that point. There we are. Questions so far? Yeah, when we're done, I'll pull up the homework and I'll show you exactly like the one I was referring to that doesn't have a good X-intercept. You only have $6 to spend on apples and bananas, or you could go and get a pretty decent sized meal at McDonald's, but that's not healthy. So it says graph the equation 1.5x plus 0.6y equals 6 using the intercepts, where x is the number of pounds of apples. So x is the pounds of apples axis, and y is the pounds of bananas axis. Pounds of bananas over here for the y axis. And so you can tell pretty easily where these numbers came from. The bananas are 0.6 or 60 cents a pound, and the apples are 1.5 or $1.50 per pound, just like we did the Swiss cheese problem. It's kind of the same thing. So it wants us to graph it instead of using slope-intercept form, using the intercepts. So if I plug in 0 for what number? What variable? Y, I'll find the X-intercept. So if I do that, that's going to give me 1.5x equals 6. And what is 6 divided by 1.5? Jacoby? 4. You are correct. Now, if you're wondering how I want you to write your answer, does he want me to write x equals 4? Or does he want me to write 4,0? I will accept either. X equals 4 means an X-intercept of 4. So the maximum amount of apples I could buy is 4 pounds. That's if I bought 0 bananas. I could buy 4 pounds of apples. That's one way I could do it. The Y-intercept is going to tell me the maximum number of bananas you could buy, assuming you buy 0 apples and plug in 0 for what variable? The X. Yeah. So if you plug in 0 for X, then you're going to get 0.6 Y equals 6. What's 6 divided by 0.6? This guy? 10. Y equals 10, or 0, 10. So that would be up here on the y-axis, all the way at the top. Can I buy in between values? Can you buy half a pound of bananas or like a couple ounces? Yeah, sure you could. Christian, you doing all right back there? Okay, so there's my line. It says interpret the intercepts. If you were listening, I already did that. The X-intercept is the maximum amount of apples you can buy. So 4 pounds of apples is the max you can get. Or what's the Y-intercept? The maximum pounds of bananas. You could get 10 pounds of bananas. And that would be the max for those. Or maybe you don't want 10 pounds of bananas. Maybe you want some bananas and some apples. And so you can get any of these in-between values. For example, that right there is a really good in-between value. You can buy 5 pounds of bananas and 2 pounds of apples, and that would be exactly $6.
Of course, it also depends how many apples are in a pound and how many bananas are in a pound.
Well, it depends on the size of them. You're right. Okay. Let's look at big ideas.
Maybe you're like a peasant. Big idea.
Go ahead and get logged in. We have 10 minutes left. You can get some homework done, or for some of you, you can fix some of the homework. I do. Okay, I'll let it know. All right. Julia, you're getting picked up.